It's too early to draw very many conclusions, but the open source nature of the model means that any biases or filters built into the model should be discoverable in the publicly available weights, which is a fancy way of saying that it's hard to hide that stuff when the model is open source. In fact, one of my first tests was to ask Deepseek what famous photo depicts a man standing in front of a line of tanks. It correctly answered the Tiananmen Square protests, the significance of the photo, who took it, and even the censorship issues surrounding it. Of course, the online version of Deepseek may be completely different because I'm running it offline locally. And who knows what version they get within China, but the public version that you can download seems solid and reliable. So why does all this matter? Well, for one, it dramatically lowers the barrier to entry for AI. Instead of requiring massive infrastructure and your own nuclear power plant to deploy a large language model, you could potentially get by with a much smaller setup. That's good news for smaller companies, research labs, or even hobbyists looking to experiment with AI without breaking the bank. In fact, I'm running it on our AMD Threadripper that's equipped with an NVIDIA RTX 6000 ADA GPU that has 48 gigabytes of VRAM, and I can run the very largest 671 billion parameter model, and it still generates more than 4 tokens per second. And even the 32 billion version runs nicely on my MacBook Pro, and the smaller ones run down to the Aura Nano for $249. But there's a catch. Building something on the cheap has some risks. For starters, smaller models often struggle with the breadth and depth of knowledge that the larger ones have. They're more prone to hallucinations, generating confident but incorrect responses sometimes, and they might not be as good at handling highly specialized or nuanced queries. Additionally, because these smaller models rely on training data from the larger ones, they're only as good as their teachers. So if there are errors or biases in the large models that they train on, those issues can trickle down into the smaller ones.